Now that we've become more familiar with vector problems, we're going to do an IB vector problem. You'll notice IB writes their vectors slightly differently than what we've been doing. So they're writing vector OA, which represents a vector starting at the origin and ending at point A in stacked component form. So the -1 is the X component, the 0 is the Y component, and the 4 is the Z component. The first thing they want us to do is find vector AB. If we think back, we know that vector AB is found by doing the terminal minus the initial. So in this case, the terminal point would be B, so that's 4, 1, 3, minus the initial point, which is -1, 0, 4. When we combine those, we get 5, 1, -1 as our vector. The next thing we're asked to do is to find the absolute value of vector AB. Absolute value means the same thing as the magnitude. So the magnitude of vector AB is going to be 5 squared plus 1 squared plus -1 squared, which is the square root of 27. 27 breaks down into √3 times √9, so we can break that down into 3√3. The next thing IB tells us is the point C is such that vector AC is equal to -1, 1, -1. Show that the coordinates of point C are -2, 1, 3. Remember, when IB says show, they want you to do all the work, and then your answer is going to be -2, 1, 3. So vector AC is going to be the terminal minus the initial is going to equal AC. So we don't know point C. Okay, we have to pretend we don't know it. But C we can find by doing AC plus A. So if I look back up, they tell me that AC is -1, 1, -1, and that A is -1, 0, 4. When I combine these, I get -2, 1, 3. Now, another hint here is because they're using the term show, the reason they usually do that is because you're going to need this answer later. So if you can't get this answer, you can't continue later with the question. So that's a little hint that we'll hold on to for later, that we're probably going to need this to continue solving. Part C says the following diagram shows triangle ABC. Let D be a point on BC with the acute angle ADC equals theta. Write down an expression in terms of theta for angle ADB. So ADB is this angle over here. So we'll notice that ADC is a straight line, which means this is 180 minus theta. Now remember, an expression means we don't need an equal sign. Now we want to write down an expression for the area of triangle ABD. So ABD is this triangle I've outlined in red. Thinking back to Unit 1, we learned an area formula is 1/2 AB sine of C, where A and B are sides that are adjacent to angle C. So if I look at what I have, I can do 1/2 BD times AD times the sine of 180 minus theta. Part D says, given that triangle ABD divided by the area of triangle ACD equals 3, show that BD over BC is 3/4. So once again, it's a show problem, so that's where I'm trying to get at the end. At the beginning, I'm going to start with what I'm given. So I'm given the area of triangle ABD, so I just wrote an expression for that. So it'll be 1/2 BD times AD times sine of 180 minus theta over, now triangle ACD, that's the triangle here in green. So I would have 1/2. One of the sides here is DC. The other one is AD. And then I have sine of theta, and that has to equal 3/1. Looking at this, since it's all multiplication, the 1/2s cancel, the ADs cancel. And if we think back to our unit circle and learning about our reference angles, we know that sine of theta is equal to sine of 180 minus theta. So therefore, those also cancel. So I'm left with BD over DC is equal to 3 over 1. Now, that's not what I'm trying to find, though. I need to show that BD over BC is 3/4. So when I look back at my picture, BD is this piece I've highlighted in blue, which is 3, and DC over here is 1. BC would be the whole thing. So I know that if BD is 3 and DC is 1, BC is going to be equal to BD plus DC, which means BC is going to be equal to 3 plus 1, which means BC is equal to 4. Therefore, I can say that BD over BC is equal to 3 over 4. Okay, so I've gotten where they wanted me to get. Now it says, hence or otherwise, find the coordinates of point D. When it says hence, that means that we're going to use what we just found. Because it says otherwise, it means you can make up any other way that you want to and still get credit. If it just said hence, you have to use what you just did. You can't make up another way. Here they let us make up another way, but I don't want to because I just did all this work, so I may as well use it. So I know that BD over BC is equal to 3/4. I also remember that I found the coordinates of point C up here. They made me do it. They didn't tell me why, which leads me to believe that I'm going to need it here. So -2, 1, 3. So I'm trying to find the coordinates of point D. Based on this ratio, if I cross multiply, I get BD is equal to 3/4 of BC. So I don't have vector BC, but I can find it because I know that the coordinates that correspond with B would be 4, 1, 3 from that vector at the beginning. Using terminal minus initial, BC would be equal to -2, 1, 3 minus 4, 1, 3. So it tells me that BC is equal to -6, 0, 0. So I can say that BD is equal to 3/4 of -6, 0, 0. Now, they want me to find the coordinates of point D. So thinking back, I know that D minus B would be the same thing as vector DB, and that's going to equal 3/4 times -6, 0, 0. Adding B to the other side, I get D is 3/4 of -6, 0, 0, plus vector B, which looking back, B was 4, 1, 3. So that tells me D is 3/4 times -6 is -9/2, 0, 0. Getting a common denominator, that would be 8/2, 1, 3. Combining, I get D is located at the point -1/2, 1, 3.